Hello viewers, Rowa taking you through the story for A-level pure mathematics. And this video we are going to go through the marking guide for senior 5 math part 1 mod 3 for the year 2024. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So we shall start with section A. Question 1 says, solve the equation sec theta equal to sec 2 theta, giving all the roots between negative 180 degrees to positive 180 degrees. So the first thing to do is to change this, because we know that sec theta, sec is the same as 1 over cos. So getting the reciprocal gives you, this becomes cos theta and this becomes cos 2 theta. The next is to use double angle property to change the 2 theta to theta. So cos 2 theta becomes 2 cos squared theta minus 1. These identities are available in the logbook. So collect like terms to get a quadratic equation in cos theta. Then use the quadratic formula to get the two values of cos theta, after which you shall get the inverse, and that is what they wanted. Question 2 still is trigonometry. It says solve the equation sine 4 theta minus sine 2 theta equal to sine 4x minus sine 2x equal to cos 3x for angles of x ranging from 0 to 180 degrees. So we shall come and write what is given. Then we use here factor formula. So factor formula here, sine minus sine gives cos with a bigger angle. That's why when you say 4x plus 2x is 6x, when you divide by 2 you get this 3x. Then 4x minus 2x is 2x, divided by 2 you get this x. So it is cos which gets a bigger angle because of the minus. After that, realize that there's something is common here, so put everything on one side and factorize out what is common, meaning that either this is equal to 0 or this is equal to 0. So for cos 3x equal to 0, we shall get 3x being equal to this. Then we get the values of x by dividing by 3 throughout. For sine x equal to 0.5, we shall come up with values of x as those. And that's what they wanted. Okay, so question 3 says, solve the equation, this one. Now this is under algebra. One is to let y be equal to 6 to the power x. Then you come and substitute for 6 to the power x here, y. This one there is a negative, that's why you see 1 over y. So multiply followed by 3y to get this quadratic, which can be solved using the quadratic formula to get the two values of y. So, but remember that y is 6 to the power x, so come and replace here and here. Then to get the values of x, we introduce log base 10 on both sides to come up with this or this, and that's what they wanted. Okay, so that was question 3. Then question 4 says, find the maximum and minimum values of this. So you shall need to differentiate and equate to 0. So let y be equal to this function. Then it's a quotient, so you shall differentiate. Differentiate means you keep this constant, which is here, and differentiate x squared to give you 2x. Okay. Then minus, keep the numerator constant, and differentiate the denominator to give you 2. Okay, then divide by the square of the denominator. That's what they call quotient formula. After that, you open brackets to give you this. Then from here, realize this and this can reduce to give you 2x squared plus this 2x. So for maximum or minimum, the derivative is equal to 0. So it shall equal to 0. Cross multiply, this goes away. You remain with only this. But here 2x is common, that's why I factorize it out. Meaning that either x is equal to 0 or x is equal to negative 1. So they told you to find maximum and minimum. So one of it is maximum and the other is minimum. So you have to substitute. But before that, you have to test to see which one is really maximum and which one is really minimum. So sign of change, we shall come and put for left hand side here to be positive, here to be negative, negative, positive. Meaning of the nature, this is maximum and this is minimum. So you shall now come and get the maximum value when x is negative 1 and also minimum value when x is equal to 0. And that's what they wanted. Then question 5 says P is a point on the curve this, and O is the origin. Find the locus of the point M that divides the line OP in the ratio of 2 to 3. So let P be a point with coordinates AB, which are not known. Then M, which is the variable point, will have coordinates capital X, capital Y. So you're using capital letters because already small letters are here. Then O is the origin. So the ratio, they said M divides OP in the ratio 2 to 3, meaning that OM to MP is 2 to 3. Using ratio theorem, OM will be equal to 2 over 5 OP, where this 2 is coming from here and 5 is coming from the total ratio of OP. Then substitute for OM and also for OP. You realize that when you make x here, x will be equal to 2 over 5a, meaning that a is that. We are using that, we are eliminating a because they want the locus of M. So it is M, it is variables of M which should remain. That's why we are making these ones the subject so that they can be eliminated. So same applies to Y. But remember that this point lies on this curve. So that means that the coordinates of these coordinates satisfy this equation. So we can substitute for A and B here in this equation to come up with B squared is equal to 8A. But the good thing, we have A in terms of capital X and B in terms of capital Y. So come and substitute, simplify, and get the equation they want. So that will be the locus. Question 6 says, find the equation of the circle that touches both positive axes and its center lies on the line that. So here it is better to make a simple sketch, though it doesn't carry a mark. So shall draw a circle to touch both positive axes with a center lying on that line. So that means that this is the radius. And also, this is the radius. Do you know what that means? It means that this point has coordinates RR. And this point lies on this line. So it can satisfy the equation of this line. Therefore, we shall come and substitute for this point into the equation of this line. To come up with that, you realize that we have only one unknown which can be got. So R is 2, meaning that now we know this coordinate. 2, 2, and you also know the radius, which is 2. Therefore, from the general equation, it will be x minus 2 everything squared plus y minus 2 everything squared equal to r squared. So we expand and collect like terms, and that's what they wanted. Question 7 says, find the equation of the tangent to the circle this at the point this. So this is the circle. We shall differentiate implicitly. So 2x gives you, differentiate x squared gives you 2x. Differentiate y squared gives you 2y divided dx. Differentiate 10x gives you 10. So our aim is to make dy dx the subject. And that is it. Therefore, at this point, you can substitute for x is 2 and y is 4, meaning you can get the gradient of the tangent at that point. Substitute for x and for y to give you 3 over 4 as the gradient of the tangent. Therefore, now the equation of the tangent will be given by equating the gradients. Change in y over change in x is equal to this. Cross multiply and make y the subject, and that's what they wanted. Then question 8 says, if this is the sum to n terms of a series, prove that its nth term is this. So it's the sum of the first n terms of a given series. Now they want the general term. So sum of the first n terms, then sum of n minus 1 terms will be given by replacing where there is n, you put there n minus 1. Where there is n, you put there n minus 1 to come up with this. So when we subtract, we shall be able to get the nth term. Subtract this from this. So Sn minus Sn minus 1, here it should be Sn minus 1. It gives you this minus Xn minus 1. So getting LCM, you come up with that. Expanding this, you come up with this. Then next is collecting like terms. Realize that 3n squared cancels. Then here this and this gives you negative 2n. But negative 2n with this, it cancels, because negative 2n with this gives you positive, which cancels with that. So I remain with the negative of negative 1, which is positive 1. And you realize that this is what they wanted. So that was section A. Now we shall go to section B. Question 9 says, part A, if alpha and beta are roots of the equation this, find the equation whose roots are this. I think let's begin with that. So 1 for the given equation, sum of roots is 4, product of roots is 2. Therefore, for the given roots, sum of roots, it will be got by adding, where you get LCM, but this one can be simplified to this. Then you can substitute sum squared minus 2 times product over sum to give you 3. Then also product, you multiply. So this times this gives you alpha beta squared. This times this gives you alpha plus beta squared. The good thing here, we already know, okay, here this is the same as alpha, beta, everything squared. And here it is alpha plus beta, everything squared. So what we have done, we have pulled out the square root, the square, to put it outside the bracket. So product is 2, sum is 4, everything squared gives you a quarter. Then now you can quote the required quadratic equation by substituting the sum and the product. So that was part A. Then part B says the polynomials x, this one and this, leave the same remainder, not this word, same remainder, when divided by x minus p. Okay. Find the possible values of p and hence determine the remainder for each value of P. So when you substitute x equal to P in both, we get the same remainder. That's why we equate the two. So here we have calculated like times when this and this cancels. When this goes this side, 4 minus 1, 4 minus 3 is 1. That's why you see P squared here. Then this one goes this side. Negative 2 plus 1 gives you negative 1. That's why you see negative P here. Then this goes this side. 1 minus 7 is negative 6. That's why you see negative 6 here. So that is the quadratic, which can be solved using a quadratic formula to come up with two values of P. Then for the hence part, the remainder when P is this will be given by substituting for P to give you 13. Then when P is 3, still substitute 3 in the expression for remainder to give you this. And that is what they wanted. Question 10 says, part A, the total cost of producing X television sets per day is this, and the price at which one, know that word, here it was producing X, but here it is just one set, is this. Determine the number of television sets that must be produced each day to obtain a maximum total profit. So know that total profit is equal to selling price minus buying price. So selling price for X television sets is got by multiplying. Therefore profit will be selling minus buying. Simplify. So what I've done, I've opened this bracket to give you this. Then simplify to come up with that expression. So for maximum or minimum, you differentiate and equate to 0. So we'll come up with X as 10, and that's what they wanted. So part B says, a point moves on the curve this, so that this X is equal to this, where T is time. Determine the rate of change dy dt when T is 4. So let's first see the allocation for this. Then you can now go to part B and say, we know that y is equal to that, implying that when I differentiate I come up with this. Then x is equal to this, when I differentiate I come up with this. So when t is equal to 4, dy dx will substitute for here, you come up with 1 over 8. And x substitute here to come up with 4. And also dy dx substitute here to come up with this. But the question was dy dt, so I'll use chain rule. Dy dt is equal to dy dx times dx dt. Substitute for dy dx and dx dt to give you the required answer. And that's what they wanted. Question 11, part A says, by expressing this in the form this, where r and k are constants and alpha is an acute angle, solve for x between 0 and 180. So that is what is given. First we have to change in terms of cos and sine. So cot is the same as cos over sine. Cosec is 1 over sine. So multiply throughout by the LCM to come up with that. Rearrange to get that. Then I can use our formula. So the whole of this will be equivalent to this. When I expand this, I come up with this. Then I can compare. By comparison, r cos alpha is equal to root 6. And r sin alpha is equal to root 3, which is here. Therefore, Pythagoras theory, I come up with the value of r, and when I divide, I come up with the value of alpha as 35.26. Therefore, when I can now substitute for here, r is that, alpha is that, equal to root 5. So take this on this side, you come up with this. Then inverse, you come up with the value, the required angles. So this inverse of this gives you this. Then take this side, you come up with these values. Then divide both throughout by 2, you come up with that. And that's what they wanted. So that was part A. Then part B says, if x equal to cos theta, if x is equal to cos theta, use the identity this to solve the equation this. So first we have to substitute for x. So you come and substitute for x. Then rearrange, take this on this side to come up with this. Divide throughout by 2 to get this. So remember that this is the same as cos 3 theta. So I can now substitute and get the values of 3 theta and then finally the values of theta. But they want the value of x, and remember x was cos theta. So when theta is 20, I can get x1. When theta is 100, I can get x2. When theta is 140, I can get x3. And that's what they wanted. So now we shall go to question 12. Part A says, at the beginning of every year since January 2023, a lady started depositing 3 million with a certain finance institution that offers a compound interest of 15% per annum. If she makes no withdrawals, develop a mathematical model that will assist her determine how much she will have accumulated by the end of 2034. Note that word, by the end of 2034, and hence calculate this amount. So let's start with that. So 15 is the rate, 3 million is the principal, and the number of years is the difference plus 1. Why? Because even this 23 was inclusive to give you 12. Therefore, amount at the end of the nth year is got from the formula of compound interest, which is given by, so substitute for P and for R to get this. But because she deposits every year, we have to get the cumulative total. So add A1, A2, A3 up to A12. So here, when I substitute, remember that this is common, that's why I factorize it out. Then I substitute for n equal to 1, n equal to 2, n equal to 3, up to n equal to 12. Then I realize that this is a GP with first term as 1.15 and common ratio as 1.15. So substitute for first term, common ratio, and n to get the required amount. And that is what they wanted. Then part B, the sum of 3 terms in an AP is 30 and the sum of their squares is 398. Find the numbers. So one, we shall let the numbers be a minus d, a, and a plus d. Their sum is equal to 30. Simplify, you can get the value of a as 10. Then the sum of their squares is 398. So square this, square this, square this to get 398. Expand, this gives you this gives you this. simplify. The good thing, we know the value of A, so substitute for A and remain with only D as an unknown. So make D the subject, it will be plus or minus 7. So when I use D equal to positive 7, I'll get this as the terms. Alternatively, I can take D as negative, still I'll get the same as that. And that's what they wanted. Then question 13, part A says, solve the simultaneous equations, these ones. I think let's begin with that. So we have that as equation 1 and this as equation 2. So when I subtract, I'll come up with, so this minus this gives you x squared, this remains, then this and this, you get 0, so this minus this is negative 1. When I take xy this side and this on this side, I'll come up with this, then make y the subject, I'll come up with this. That means that when I square both sides, I'll get y squared as this. So what I'm going to do, I'm going to substitute equation 3 into equation 1. Where there is y squared, I'll put there this. So multiply followed by the LCM, which is x squared, you come up with that. Collect like terms to get that. So I can now use the quadratic formula to get the values of x squared. Then put square root on both sides to get plus or minus. So when x is plus or minus 1, I'll come up with y as this. When x is plus or minus 0.5, I'll come up with y as that. And that's what they wanted. So that was part A. Then part B. Part B says express in partial fractions this. So one, you have to realize that that's an improper fraction because the degrees are the same. So we have to first do some long division. Show the divisors there and the numerators there. So we can divide, so this divided by this is 1, that's why you see 1 here. Then 1 times the whole of this to come up with this. Subtract the 2, you come up with that. So now I can say that this can be split to become 1 plus this over this. So let this, now we shall deal with this one alone. So let this be equivalent to this. Equivalent of the numerator is that. So putting x equal to 0, this is 0, you get negative 2. And here this goes away. Here put 0, you get negative 3. So negative 3a is equal to negative 2, being that a is equal to 2 over 3. Putting x equal to 1, here it becomes that, here it becomes that, and here it becomes that. The good thing, I know the value of a, so I can make be the subject. Therefore this is equal to 1 plus this, and that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded to study your video.